Polarity. What is polarity, and how does a molecule attain this property called polarity? Well, polarity is created when two atoms joined together by a covalent bond share their electrons unevenly. This occurs when one of the atoms participating in the bond has a stronger affinity for the electrons, a higher electronegativity. This uneven sharing of the electrons in a bond creates what is called a polar covalent bond. If the two atoms sharing the electrons have the same or similar affinity for the electrons, similar electronegativities, then they share the electrons evenly and no polarity is created, in which case it is called a non-polar covalent bond. With all the different atoms on the periodic table, trying to figure out whether a bond between two of these atoms is polar or non-polar may seem like a daunting task. But when discussing molecules in the body, it's actually quite simple to learn what molecules are polar and non-polar, and that is because only four atoms, carbon, hydrogen, oxygen, and nitrogen, make up more than 96% of the mass of living things. These four atoms are therefore the only atoms that contribute significantly to polarity in the body. It is therefore quite easy to learn which interactions between these four atoms are polar and which are not by learning a few simple rules. 1. Any bond between two of the same atoms is always non-polar because the same atom obviously always has the same electronegativity as itself. 2. Carbon and hydrogen always form non-polar bonds when they bond with one another because carbon and hydrogen have similar electronegativities. 3. Oxygen has a higher electronegativity than both carbon and hydrogen, so when these atoms bond together they form polar covalent bonds. And lastly, nitrogen also has a higher electronegativity than both carbon and hydrogen, so when these atoms bond together they also form polar covalent bonds. Now let's look at some common molecules in the body and see if they contain polar or non-polar covalent bonds. Let's start with the most abundant molecule in the body, water, H2O. Water is a polar molecule because it is composed of an oxygen bound to two hydrogens. The oxygen is more electronegativity and so holds the electrons tighter, creating a negative pole in the molecule, and the hydrogens hold the electrons less tightly and so create positive poles. As such, it behaves like a magnet. Molecules like water that are polar interact well with other molecules that are polar because their magnetic poles draw them together. However, nonpolar molecules do not share this magnetic-like property, and so do not mix well with water and other polar molecules. Let's now look at all the major classes of molecules in the body: fats, carbohydrates, proteins, and nucleic acids in terms of their polarity. We'll start with fats. Fats, otherwise known as lipids, are the only major class of molecules in the body that are nonpolar. For this reason, they do not interact well with water or other polar molecules. We see this when we pour fats into water. They separate. Why? What makes fats nonpolar? Let's take a look at a fat molecule to see why. Here's a fatty acid, stearic acid. It is composed of a long chain of 18 carbons with hydrogens attached. All of the carbon-carbon bonds are nonpolar and all of the carbon-hydrogen bonds are nonpolar. And like stearic acid, all fats in the body are composed almost exclusively of carbon and hydrogen. Because of this, they are composed of mainly non-polar bonds and don't interact well with water or other polar molecules. The other classes of molecules in the body, carbohydrates, proteins, and nucleic acids, are polar. This is because they contain oxygen and or nitrogen mixed in with the carbon and hydrogen atoms, and this creates significant polarity. Carbohydrates have a similar structure to fats, being composed of carbon chains with hydrogens attached. However, every carbon in a carbohydrate also has an oxygen attached. Oxygen forms polar bonds with both hydrogen and carbon, so adding an oxygen to each carbon creates a large amount of polarity in these molecules. Therefore, carbohydrates are polar molecules. Proteins and nucleic acids, the other major classes of molecules in the body, are very large molecules that contain significant numbers of polar covalent bonds, and so are also polar molecules. Two other very important non-polar molecules in the body are oxygen and carbon dioxide. Carbon dioxide is composed of carbon and oxygen, so you may expect it to be polar. However, the small and symmetrical shape of this molecule actually make it a non-polar molecule. In summary, there are two types of covalent bonds: polar covalent bonds, which are created by unequal sharing of electrons, and non-polar covalent bonds, created when there is an equal sharing of electrons. Most of the molecules in the body are polar. This includes carbohydrates, proteins, nucleic acids, and water. Polar molecules mix well with other polar molecules and with water, but do not mix well with nonpolar molecules. Fats, oxygen, and carbon dioxide are some of the main nonpolar molecules in the body. Nonpolar molecules do not mix well with water and so need special treatment in the body. All of our videos come with a multiple choice quiz, a short answer test, and a Public Kahoot that can all be accessed free of charge. The information for these resources can be found in the description below, or you can click this next video that explains how to easily access all these great resources. And if you're enjoying our videos, please hit the subscribe button.